pilots, crew chiefs, and troop leaders prepare for the coming operation. Night flight is not inherently dangerous. Night flight close to the ground in combat is always dangerous. Planning, rehearsal, preparation must be meticulous. Planning completed, the lift ships take off for the rendezvous area and the waiting troops. Approaching the pickup zone, the ships are directed to carefully selected positions, there to be married to the tactical unit they will carry into night combat. The formation assembled, the troops and equipment are rapidly loaded and the UTAS immediately departs, beginning the long black hours of deployment, redeployment, and support as the enemy situation is developed. Before the operation is completed and the objective won, the plan may be changed or modified, and the lift battalion commander must have the flexibility to adjust to the maneuver commander's new objectives. When the Army issued the request for proposal for the Utility Tactical Transport Aircraft System, the UTAS, it set new standards for performance, maintainability, air transportability, survivability, and crashworthiness. A vital requirement in the performance category is maneuverability and control response in the nap of the Earth flight, to include frequent landings and takeoffs from unprepared landing zones. The objective? To get in and out fast with minimum enemy exposure. At 4,000 feet, 95 degrees temperature, using 95% of power, the UTAS rate of climb is 480 feet per minute with a full mission fuel and 11 fully equipped combat troops. Under these same conditions, the Army's previous utility helicopter could not carry troops. The UH-60A cruises at 147 knots and has a dash speed of 163 knots, compared to the Army's previous 90-knot capability. Since the UTAS cargo compartment is 86% greater than the Army's UTAS predecessor, it can comfortably seat the 11-man squad with space for all specialized combat equipment. The UH-60A cargo book is rated at 8,000 pounds, almost equal to the aircraft's own empty weight. This capability was demonstrated by the lift of a Gamma Goat cargo carrier. With this new combat assault helicopter, the Army has the ability to transport the 105mm howitzer, complete with ammo, netting, and ground crew, thereby retaining weapons crew integrity. Fully qualified to fly in Instrument Flight Rules (IFR) conditions, the UTAS is equipped with the most advanced avionics package ever installed in an Army production helicopter. This package includes a command instrument system, CIS, which complements a wide variety of navigational radios. The CIS provides the pilots with steering commands to maintain course and glide slope, as well as slowing the aircraft in preparation for breakout at minimums. The Stability Augmentation System, SAS, provides airspeed hold, attitude hold, and coordinated turn capability. Pilot and co-pilot each have their own full-flight instrument panel, making it possible to fly IFR from either seat with ease. Highly reliable, solid-state, color-coded fiber optics displays are another unique feature of the UH-60A cockpit. These displays, featuring no moving parts, have a mean time between failure ranging between 4,800 hours and 7,000 hours, which far exceeds reliability of previous systems. The Army established very high reliability and maintainability goals for development of UTAS. The UH-60A meets and in many cases exceeds these stringent standards. Reliability is greatly enhanced by very low vibration levels throughout the aircraft. Low vibration is achieved through efficient airframe tuning and a bifilar vibration absorber which dampens vibration at the source, the main rotor head, before it feeds into the main transmission and airframe. Wherever possible, components are simplified, interchangeable, and easily accessible for repair and replacement. And the need for lubrication is minimized. The main rotor head, for example, has 65% fewer parts and weighs half as much as a similar-sized previous rotor head. The Fluidic Stability Augmentation System, SAS, is completely independent of the aircraft electrical system, thereby allowing stabilized flight even with electrical system failure, 5 to 10 times greater than a comparable electrical system. The elastomeric bearings in the propeller-like rotor hub, made of rubber and steel laminates, provide full articulation and require no lubrication. The main transmission has almost 35% fewer parts and weighs more than 20% less than a similar previous transmission and consists of 5 self-contained integrated modules. The 2 input and 2 accessory modules are interchangeable. The tail rotor has no bearings and needs no lubrication. Blade flap and pitch change motion are provided by deflection of the flexible graphite epoxy spar. The tail rotor is canted 20 degrees to provide better center of gravity range while shortening the overall length of the helicopter. Electronic components are centralized in the nose section, allowing greater accessibility and shorter harness to the pilot's indicators. All panel instruments can be removed from the front of the panel with a screwdriver. The UTAS is capable of rapid strategic deployment worldwide. It is air transportable in the C-130, the C-141, and the C-5A with minimum preparation for loading and offloading. Preparation for air transport consists of removing the mast extender, folding the tail and main rotor blades, and folding the tail pylon. The Army requirement calls for being able to prepare the UH-60A for shipment in 1.5 hours, loading in a half hour, unloading in a half hour, and preparing for flight at the destination in 2 hours. Army teams bettered all of these times during tests at Fort Campbell, Kentucky. One UTAS can be redeployed easily in a C-130. 2 nest neatly, tail to tail, in a C-141. And 6 fit comfortably without lowering the rotor head in a C-5A. Self-deployment is also possible through the use of auxiliary fuel tanks in the cabin. Combat survivability will be a major threat to aircraft operating in the high-threat environment of the future battlefield. The UH-60A was built with these threats in mind. The UH-60A was designed to be invulnerable to 7.62 millimeter projectiles. In addition, extensive tests have been conducted to upgrade that capability, where possible, to minimize its vulnerability to more lethal threats, such as the 23 millimeter high explosive incendiary HEI. The tail rotor blade was also tested extensively. Shown here is a tail rotor blade spar after having been fired at by a 23 millimeter HEI. It survived 8 hours at loads equivalent to cruise conditions and 30 minutes at loads equivalent to maximum maneuver loads. There was no propagation of damage. UTAS fuel cells have been fired at by 12.7 millimeter and 14.5 millimeter armor-piercing incendiary API and 23 millimeter HEI projectiles. Tests included delay-fused and super-quick fused projectiles. There were no fires or explosions, and with the exception of some 23 millimeter HEI hits, there were no leaks. The UH-60A was built to be crash survivable. Just how tough the aircraft is can be seen in this sequence taken during full auto-rotation testing at Sikorsky. The aircraft encountered wind shear just at the point of flare. The UH-60A hit at approximately 2,500 feet per minute on the tail wheel and then hit again on the main landing gear. The impact ruptured the tail wheel tire and the rim was damaged. A drag beam in the tail gear structure was damaged. These parts were replaced and the aircraft flew the next day. The UH-60A fuel system is crash survivable. During the design process, a cell was dropped from a height of 65 feet filled with water. The severity of the impact can be seen here. The cell did not leak or even seep after coming to rest, signifying that the design met the stringent Army standards for crash survivability. By design, fuel is sucked from the cells, thus avoiding crash conditions where in-cell pumps continue to function after the crash, posing a serious fire hazard. The cells have breakaway fittings and self-sealing lines to further reduce the hazard of fire on impact. Crash load attenuation is achieved through dual-stroke struts in the main landing gear. The gear absorbs a 2,000 foot per minute impact before the belly of the fuselage touches the ground. Additional crash absorption is built into pilot, co-pilot, and troop seats. The design allows aircrew members and passengers to remain uninjured after a descent impact of over 2,500 feet per minute. Engines, transmissions, and other hardware are mounted so that they do not separate at crash impact. For example, blades striking trees do not cause the transmission to come loose and roll into the cockpit or cabin area. Modern warfare demands new tactics and techniques. The weapon systems to be used in any future conflict must, therefore, be designed and built to the latest advanced technology available. The United States Army's air mobile concept, in which helicopters are used to rapidly deploy combat assault troops, requires a vehicle that can operate in any terrain or climate, day or night, in all kinds of weather, any theater of operations in the world. To fulfill these demanding requirements, the United States Army properly established most stringent specifications for its new generation combat assault helicopter. The helicopter that will bring the air mobile concept to full maturity. The UH-60A UTAS, built by Sikorsky Aircraft.